Hello everybody, it's nice to be here in Tsinghua, and also nice to be here to do this presentation for you. I think I'm still, even though I've experienced a lot of other projects, but I'm also like a beginner in this startup industry. So let us together explore what could be done in Shenzhen and how these IoT, wearable, smart hardware technologies are currently being used in the industry. So a little bit about my background. I have an electrical engineering background and was involved in product design, development, prototyping, manufacturing business as before. So this is, do you guys know HAX? HAX is like an international incubator located in Shenzhen. So they are backed by a US angel investor called SOSV. And they operate in Shenzhen because of the rich resources of hardware available in Shenzhen. I could show some other slides later than this one. So we work with them since 2015, and my company is also based in Shenzhen. And most of my customers are in the US or North America mostly. I have some local customers as well. And we do consultation, design, manufacturing, and testing. So consultation means if you have any questions about how to build a product, how to start with your current funding, if you have issues that you cannot solve in mechanical, in electronics, in firmware, then you can come to me and we can help you to sort things out. For design, we work with other design firms, and I'll give an example about how they do that. We work with other design firms, and also we have an electronics team to build the PCBs. For mechanical parts and for manufacturing, we work with our partners as factories. And we do, well, 1 million units is a bit too big for us now. We could help you to go up that high, but we haven't reached any company that built 1 million units per year. These are regular testing. We work with professional labs that can get you certified in the future process. So this is our today's topics. In the beginning, I will introduce some basics about how to build a hardware prototype in Shenzhen. And then why do people come here? Because of the local advantages. And third, startup, I will give you some examples about those units. You can see it over there, some companies that come here. And then the last part is some experiences for myself to be in a startup company, like the risks, the benefits, and also something that would always be a surprise for you. So the first part is introduction. Why do people today make hardware? I ask people quite a lot. Any of you here, you're willing to live a life without electricity? Anybody? No? Okay. So why is that? Because we need electricity all the time. And whenever you need electricity, you need an electronic product, a hardware product. That's why hardware is still a very important sector. It may not be the uprising new sound, new trend, but still it's going to be a major industry over the long term. So as long as human race need electricity, you will need a hardware electronic product. That is for sure. And then how to build the hardware? We have an idea, and we somehow turn it into a prototype, and then somehow we turn it into a product. So this, I will give you an example about how we go through things step by step. But before that, we have some terminologies that we have to study today. The first terminology is called POC, proof of concept. That means an idea. That means you have something in your mind, you have to build a very rough version of the product. It could be from foam tapes, it could be from a cardboard, it could be from the mud that played by the children. Something that you show to people. For example, if you have a mouse, you have to determine how big the mouse is. If you design an ATM, you have to determine where should I withdraw money, from here, from there, from here. That's kind of early stage thinking is called proof of concept. And then we do prototyping. The first stage is called engineering verification. This means you throw away your POC. I mean, you can keep it in the museum, but you have to throw away all the elements over there and redesign everything through engineering way. That means everything has to be associated with electronic engineer, firmware engineer, hardware engineer, or mechanical engineer, software engineer, etc. Everything has to make sense, has to be scientific. If you want to say, hey, I want to build a Bitcoin miner on my watch, is it feasible? No, absolutely not. The power consumption is too high. Your watch is definitely not going to support that kind of computation power. You will mine maybe 1 Bitcoin in 1 billion years if you are using your watch. So something has to be very scientific and carefully designed, engineered. And then after we do that, we do a design verification. When we say this, it means the product looking has to be locked. For example, previously you could have 10 different versions of the product, and then you select which one would be better, and you make it smaller, and eventually you shrink it down to the size of a watch, and say, okay, this is the watch I want to build. I'm locking the design now. I cannot change how the design looks like in the future. So this is called design verification. And after that, we'll be prepared for production. So we'll have some trial productions, like 100 pieces, 500 pieces, even 1,000 pieces before you eventually ship your 10,000 pieces or 1 million pieces. This is called product verification. You have to validate your factory. Your partner is capable of delivering everything. And then the next stage will be mass production, which is, go to production line, you have the workers do things step by step and ship everything. So POC, EV, PV, MT. This is the regular process we use for designing and prototyping and manufacturing a regular hardware product. We'll start from the idea phase and see with an actual example about how product can be designed and improved along the way. This is from my friend's company. They're called Innocent Design. They are an industrial design company based in Shenzhen, and they also do a lot of designing for international customers. So this is a 3D printing pen. It's a pen, handheld pen that can 3D print something. So they did 7 weeks from concept into a functional prototype. So how do they do that? Let's go this way. Initially, when they first meet the client, they were given this kind of concept. Oh, I should have a tube for the liquid. I should have something in the front and maybe have a pen look like thing, but that's like a very initial design of the item. Like we have no idea about how that should work, and we have nothing to know about the manufacturing process. And then after that, they were doing some research and brainstorming. You can see that the designer here is holding a wrapped paper in her hand because she wants to know what's the best position, what's the best gesture to hold a pen. How can I do something comfortably while also having a printing very carefully and very accurate. They were doing a lot of iterations and also learned a lot of things from the pen, like the touch pen from the tablets or some kind of office pen that regularly you write. You have to learn from the human-machine interaction design. You have to make it very scientific so that whatever you use, whatever you write, will be very accurate and you're comfortable with it. The next part is about drafting. You have to come up with a lot of sketches. You can see all these kind of concept sketches. Some are with pen, some are not, but basically you write a few lines or some curves and you have to determine should this pen be aggressive or be polite or classical or be scientific in the future, whatever. These are going to be the draft stage. And after drafting, you come up with concept design. So this is the first concept they come up with a pen. It's you see it's called Art Loom. It's kind of classical with pen, with plastics, and with everything, the button to move things forward and background. And the liquid is stored inside. And that's the second pen. It's called supersonic. So if we compare this design with the previous design, you could tell the difference. This one is more like conventional, more health map, more like a general design. But this supersonic design is more like aggressive, more future-like. You would probably see this kind of color and this kind of sharper edges in a sci-fi movie, like Star Trek or something, like supersonic. This is the second design. The third design is with a space rocket. So they were following a Russian space rocket design style to make the color and touch of this design. So you could see that this is black and silverish, and along this way it looks like a little bit like the rocket's body. So they were presenting that this is something that you should think about ambition, because people, whoever uses this pen, they are supposed to be designers. You are supposed to use your own design to change the world. And what do rockets do? They deliver satellites. They are also changing the world. So you need to give the user a great ambition about their creativity, about their product. The last one is called the feather, how do I say this? The bird feather pen. It's like a very thin design, and also it's very curved. So originally, maybe a few hundred years ago, back in Europe, people were using this kind of bird feather to write letters, and they also put this feather back to a dot like this. So the designer learned from this process and designed a similar looking. So it's bigger on the end and it's sharper on the edge. So the whole body would look more streamlined. These are the 4 designs this team prepared for the customer. And which one do you like the most?
The second one.
Second one? Okay. Other people? Third?
I like the fourth one.
You like the fourth one? This one? Okay. Well, looks like most probably like the fourth one, and that's why they chose the fourth one. So we will go into the prototype stage because after this design is chosen, I say, oh, I just want to this one. The 3 are good, but this is what I like the most. Then you should go into prototype stage. How to do prototypes? You have to be doing mechanical and electronic design. This is what they call the 爆炸 tool, the explosive view of the whole product. You see, this is the PCB. This is the main PCB that has a microcontroller, that has a motor driver, has LEDs on it. And this one is a charger board. It's used to charge and provide a power supply for this pen. And this is the top cover. These are the bottom covers. And this one here is a little bit special. It looks like a little bullet, and you can just push this bullet inside this case. What's inside the bullet is a special liquid. It's called photopolymer material. Photopolymer means it's a type of liquid, but once you put UV light on it, it will solidate and become into plastic. So it's a light-sensitive material. Before, it is stored right here, and when this liquid is pushed out to this nozzle, there will be 3 UV lights shining this material, and it will become solid. So that's how this kind of 3D printing pen works. So you do prototyping at this stage, and you also do some samples. These are not samples from the tooling factory. They're just handmade or made by small quantity machines. You only make like 5 of them or 10 of them. And these are the prototypes they assemble, and these are the electronic inside. And that's how it looks like in the actual prototype stage. And some more shots, you can see that this is a UV light. They put some purple color there to tell people that the UV is on, so that you're not staring to that. If you stare into UV light for too long, it may damage your eyes. So some pen, if they are designed for children, they have to have a security measurement that if you lift it up, it will stop working. So you're not looking into the UV light. And this is how the pen looks like. So before industrial design, it looks like this, and after that, it looks like this. So that's the how the industrial design would help to change the product looks, and also would help to bring attraction, bring art in your product. And after that, we go into production phase. So once you have a stable and mature prototype, and you also have the mature CAD drawings of everything, you should go to manufacturing. So you can see that the happy guy, the happy customer there, with all the casing, all the PCBs, and all the half-finished body. That's the process. So they do a lot of different parts in different factories, and once the different factories finish, they'll come up into one whole factory for the assembly and testing of the whole product. So, and also the package design. You can have the package design in a very beautiful way and show people. So this is called a hero image. The hero image means by looking at this image, you know what is inside the package. You know how to play with it. You know how it works. That's why a lot of people, when you go to buy electronic devices like a cell phone, a tablet, or a wristband, the hero image is very important, because if you are not attracted by the image, you're not going to be attracted by the product. You don't even want to open the product. But if this one has a really good image, then you can, in 1 second, get to know what is inside and how to play with it. You have a very, very easy way to learning about how to use it. So that's why the hero image has to be carefully chosen. And this is the back of it. You can see a lot more information about certifications, the barcode, and also more introduction about how this one will function, what it will be like, and how do you purchase the refillment cartridge. And this is unboxing experiences. So when you open it up, you could see the color. You could see these colorful printing materials, and this is a pen on this side. And you lift it up, there's more of the accessories inside. For example, power adapters, other user manuals, etc. So a good open box experiences would also be good. There's one story I get from a packaging factory that is doing contracts for very big companies. They do contracts for Apple, Samsung, Huawei, HTC, Wuliangye, Maotai, a lot of different companies. It's a very big factory. And originally when Apple was doing their products, like the Apple iPhone and iPads, they have a very strict requirement in one thing. They have a lot of strict requirements. One of them is when you open the plastic wrap, there's a top cover and bottom cover of the package, right? Top cover and bottom cover. So when you lift up the package, the bottom cover will be dropping down. The dropping speed has to be very precise at some centimeter per second with a very precise speed control. And only one factory won that in the initial version. So only that factory got the order and became very big. Later on, other factories began to improve their production accuracy, and they satisfied the Apple's needs, so they have more orders. So if you or your friends have any kind of new Apple products, they still have the case, you can just try it. Like with the whole product, with the whole accessories and the manual inside, when you lift up the box, the lower box will just travel at a steady speed. That's for sure. And that's the first example we learned about product design. And then I will introduce about something more in details about electronics and mechanical techniques, but not too professional, so all of you can still understand it. One of the concepts we call is called PCB, printed circuit board. It is the basement of electronics. Like everything you do inside this kind of electronic components, you need to have a PCB. Without a PCB, things cannot work out. So this is a pad. This is used to hold and solder the components on the surface. These holes can be used to have a screw fixed onto them. So when you design your whole product, these kind of holes need to match your mechanical structure. You need to have pillars at these holes, or you need to have a mounting position for these holes. And then the silk screen is the white color on the surface. So you could put your company name, put your product name, version 1, version 2 onto this silk screen. And this green color is called solder mask. Solder mask is used to protect the surface copper from getting oxided and from getting a short circuit. And this is the outline. So for this PCB, it uses green solder mask, which is most general and most widely used color. You could also have blue color, red color, brown, yellow, purple, and also black. A lot of premium motherboards or cell phones, they use black solder mask because it's more expensive, and also repairing the boards are going to be very hard So they want to use that to prove their manufacturing ability. All Apple products are using black solder mask. You can see that if you look up, say, iPhone 6 or iPhone 7 disassembly, people taking that cell phone apart, all the motherboards are in black color. That's the reason why Apple is so expensive. What you look at is beautiful. What you cannot look at it is also very beautiful. And another thing called FPC is called flexible circuit board. So this one is an FPC. If we go back one page, this is a hard board. It's used to conduct electricity. This one is soft. It's very flexible, just like a very thin film plastic that you can just rotate into any angle, anything. One of the, I'm pretty sure a lot of you have used this before. This is a CD drive, a CD-ROM drive from laptop computer. So this part, this orange, brown part is actually the FPC because you need to have the disk out and inside. That's why when it's traveling, it can still have the connection and reading of it. So that's why we need FPC in some designs. If you have, let's say, a headset that one of the motherboard is here, the other small board is here, you might need to use FPC to connect it. Or if you have something that's like very, very small in surface or in space envelope, you have to do a lot of connections between them. You could also use FPC. But FPC in general is more expensive than PCB, than the rigid board. And a more advanced board is called flex rigid board. So look at this picture. This brown one is flexible. This dark green or black color one is rigid. So you have both rigid and the flexible one. In Chinese, it's called 软硬结合版 or 刚劳结合版. So half rigid, half flex. So the reason to use that is also due to space limitations. That you have to use a lot of connections between each of the small areas, and you have to put some components on this, and also use a connection for the flexible part. So that's why people use flex rigid board. This one is going to be even more expensive than FPC. So when you design your product based on your own budget, based on your own retail price, you have to think about this cost very carefully. This one also will take longer lead time to make. For example, PCB can be done 24 hours to a few days, but this one would likely to last for at least 1 week to 3 weeks to make because it's very complex to build. And then would come the SMT. SMT or PCBA is called surface mount technology or PCB assembly. We can easily tell what SMT is. This is a PCB, right? Nothing is on it. With SMT, we turn it from here into here. So what is the difference? What's the difference before and after? Components are now sitting on the board. So this is an empty space right here. And now we have the microcontroller STM32. This is empty right here. And now we have a small push button on the side. This one is also empty. And now we have a connector connected. So SMT means we are going to put components, solder components onto the surface and then make them a real functioning board. So this kind of PCB cannot work because there's no microcontroller, there's no brain for this board. But this one can definitely work because everything, all the elements are actually over there. So how SMT is done in the factories, I can show you a small desktop pick and place machine. So I'll play the video once and then I'll explain. Okay, so let me do more explanation. The ones you see right here, you see the little black dots? They are components. It could be resistor, it could be capacitor, very, very small components on the circuit. And this one is a vacuum nozzle. So this one will just pick up use vacuum to suck the components up and then drop it onto the surface of the PCB. So it's like pick, drop, pick, drop. That's why it's called pick and place machine. So it knows the coordinates because you have to program the machine to make sure all components will sit into the proper positions. And this one is a small desktop one, so the speed is not very fast. Should I play it again or no? Again? Okay. So I'll do more explanation. So pick, place, pick, place, pick, place. That's how it works. Okay, so this one is good for prototyping applications. If you have 5 boards or 10 boards on the build, then the speed is also okay. But what if factories want to do a lot of production? It will be wasting their time, or production cost will be very high. So in some other factory, they do the high-speed SMT machine. So that's how high-speed determines. Let me turn up the volume. What is high-speed? You can see how fast they are mounting down surface. Yeah. This one has, I think, maybe 16 or 32 headers to place the components, and these are LEDs, so they do not require very high accuracy, and that's why they can use different headers, just like machine gun, to place components onto the surface. And this is one of the reasons that Shenzhen factories, they can do a lot of production in very short time because of the high-speed machines. So when you do assembly, when you do SMT, after that, you can have a functioning board. But this will not be enough. You still need a lot more parts to make it function. Without the electronics, it cannot work. You also need something to power it up, to connect your board. So that means you need a cable. And which cable is better? Guys, tell me, which one is better? Yeah, you know Chinese, so the one on the left is better because it has good shielding. So this is aluminum foil plus a braided shield. That means when your signals are traveling inside the cable, it's being shielded, being protected by the outside case. So if you are purchasing some original cables, you have very stable connection. If you are loading a movie from the computer to a cell phone with your cable, it's going to be very fast. But if you're buying a Shanghai cable, the speed will be very low, and also the charging capability will also be very low because the shielding is not done very well. And if you have a portable product that you need to charge, then one of the ways to give people a charging cable. And Apple is using something like TPE or TPU as the basic charging material. The skin wrapping material. So it feels like very like skin, very soft, very good. This is the cable, and if you look at something right here, this is special architecture. It's called string relief (SR). Why do people do that? It's to relieve the string, because if you hold the cable like this and you have a movement along it all the time, then it's very easy for the cable to break. It's very easy for the skin to get damaged. But when you have this kind of SR, this part will be clamped by the case, and when you pull it, when you move it, it will be protected by this outer circle of. So the cable will have a longer life, and you could also customize the USB with your logo or your company name or the product name on it. It's very low cost. And the next thing about noise control is magnetic bead. So if we look at if you look at this cable, VGA cable right here, this is a connection, right? But what is this? What is this part? This is called magnetic bead or Faraday bead. This is used to filter the noise in the air when the cable is longer than 1 meter, because we live in the modern era, and a lot of the radio wave frequencies are coming into the room. Like all your cell phones, all people's radios are working. So we have to make sure the noise can be controlled on the cables. That's why we need the Faraday bead on these terminals. Another thing about the connector is this. So if we look at the connector, connectors are used to connect different cables or different boards. So this connector is a little bit special because there's a little hook right here, and there's a bigger hook right here. When you turn them around and when you push them together, these two parts will lock together. So when you pull it, it's not going to unlock, it's not going to detach. How can you detach? You have to press the lever, release it, and then it will be detached. So when you move it back, it locks. You have to release lever and detach. So this is one of the ways that we make a very stable, make a very secure connection, because your product is probably going to go to 顺丰快递 or 圆通快递, like with very brutal transportation. People just throw the box from here to there. They go to a truck, they go to an airplane, they go to a boat. Like vibrations or anything could be very risky for your product. And if the plug is loose inside, you have the customer, and the customer puts the cable on. It's not working. They say, oh, it's a bad unit, but it's actually a loose plug. So we have to make sure. If you can choose a locking device connector, that's really recommended. The next part is the foolproof design. Can anyone notice a special thing about this connector? What is special?
This is like different shapes in the shape.
Yeah. If you look at this shape right here, it's a perfectly 90-degree corners. 90-degree corners. But if you look right here, there's a small angle right here. There's another small angle right here. There's a small angle. All these are different. So this connector is made that you cannot push it the other way. You can only push it in the correct way. Why do people do this? Because imagine you are a worker working at Foxconn or a very small factory. Your boss asks you to work 12 hours a day. From morning 8 a.m. to evening like 9 p.m. or something. You're very tired. You want to go back to your dorm, play some games, or you have a girlfriend, you want to go watch TV, then you have no energy, no concentration on your work. You just do all the kind of plugging in. If we do not have this kind of foolproof design, and something happens with the reverse polarity, the whole product might catch on fire. But if you have this kind of design, when he makes the wrong connection, he will suddenly realize it's wrong, and he will move it into the correct polarity and then push it in. So that's why foolproof design is important. If you have built your own desktop PC, then you can definitely find this kind of foolproof design. Your own PC, when you push in the power and etc., there's only one way that can make it work. Okay, and something about batteries. Do I still have time? Something about batteries. So batteries, we have two types. One is called the lithium polymer batteries or soft pack batteries. The other is called the lithium ion batteries, which has cylindrical metal base. So what are the differences? What are the pros and cons of the products? The first thing is about lithium polymer. They are actually more safer, lightweight, and you can customize the dimensions. For example, you want it to be very, very thin as paper, then okay, you can customize that. You want to be longer or shorter, then you can customize the dimension. But it needs a little bit of expansion space because this one is soft. And for lithium chemistry, when you use it for a longer time, some kind of chemical gas will build up in the sealed bag. So that's why you need about 10% of expansion space for this. You guys know the Samsung Galaxy or Note 7, the cell phone that explodes. Some people say this due to the battery expansion and also the friction of the surface of the battery, that some parts would make it leak and eventually catch on fire. So this is a lithium polymer battery. And lithium ion battery, this one is called the 18650 battery. So this one has 18 millimeter diameter, 65 millimeter in length. That's a lithium ion battery. So you guys know Tesla motors, right? So on Tesla Model 3, Model X, Model S, they all use this as a very basic battery cell. So I think they work with LG or Panasonic, and these kind of cells were built into small battery blocks, and different blocks were then put together as a whole on the whole chassis of the car, so that they will become the power source of the car. So this is very mature in the industry and relatively lower cost, but it's very heavy and only certain sizes are available. If you are building a battery, a power bank, you can use this one. But if you want to build a cell phone, it's too big. You cannot put this one into a cell phone, otherwise your cell phone will be the very big, very heavy. It's not going to work. And something about certifications. So after you finish your product, you want to legally sell that to all the kind of countries. How do you do your certification? In US, you need to do FCC. In Europe, that's for CE. And in Canada, it's Industry Canada IC. In China, you have SRC or CCC. And for Bluetooth Alliance, you need DQB. And these are the chemical testing. So have any of you bought your cell phone outside mainland China? If so, could you take a look at the back of your cell phone?
No, not this one.
Not this one, okay. So if you have bought your cell phone outside mainland China, you should be able to see FCC logo and the CE logo at the back of the phone. If that's in China, if your cell phone is bought in mainland China, then you will see CCC on it. So that's why different countries would require different certifications. That's true, right? Okay, and after that we would have injection molding. Yeah. So injection molding is a type of method that can help you to make plastics in a very cheap and fast way. We use a lot of plastics. The pen, this pen is a plastic. A lot of people's cell phones case is plastic. These kind of chairs, they are plastic. The computer is plastic. Everything is plastic. So how do we make things very cheap? It's very simple. This is called an injection molding machine. I know it's very complex, but only look at the points I'm pointing at. This one is a container for plastics. Original plastic materials will get hot, be melted, come into the cylinder, and they are pushed into this kind of chamber. In this chamber, they will form the shape of your device. Let's say a laptop case, a computer case, or a button. And then when this one cools down, the mold will detach, open, and you can see the actual product. So let's use a step-by-step illustration on this one. So the first step, or the zero step, is to make a mold, like build a metal tooling. So this is a case for a USB drive, a flash drive, USB drive, U-pan. And you can see that the cases are made inside this. It's a soft material, but normally we use stainless steel. So this is half of it, this is another. And you can see that these parts are machined so that they have this USB shape. So first you need to have a mold, you need to have a tooling done. Second part, you have to select the raw material and melt them. So these are the small plastic pieces. They are bought from other chemistry factories and put into our injection molding factory. If you like red, you use this kind of red. If you use white, it's also okay. And then you melt it from here. You put it into the can, you melt it, and inject into this kind of chamber. And after the chamber gets cold, you detach the chamber, and now you get your product. So this is how the liquid comes in. When the plastic is very hot, it melts into liquid. The liquid comes from here, flows into these small cells, and form this kind of basic shape. So this looks like a button for a color button that you can have lights underneath it. So this is a detach. So by doing that, you can easily have 10 or 20 or a lot of them in a few seconds or maybe longer time. And this kind of machine can run 24 hours. So if you need 10,000 pieces or 100,000 pieces of plastics, that can be done very effectively. Okay, so that was a previous introduction about the necessary mechanical and electronic skills. And this is the overall review about the whole product. So what is POC? You guys still remember? What is POC? Proof of concept. What is EV? Engineering verification. DV, design verification. PV, product verification. And MP, mass production. So I'm going to go this way. Starting from POC, we have to make something really simple that works. For example, I need to make a mouse, I need to make a tablet, I need to make some kind of massage tool for my shoulder, I have to determine the proper size of this device. So I need to use a breadboard, tape and glue, foam board or cardboard, do some very basic tests. Is this big enough? Is it small enough? Can I hold it very comfortably? Or can I put this kind of motor inside my machine? I have to design the size. I have to determine how the product would interact with different people. And then after the POC stage, we go to EV, which means we use some big PCB, some modules we put from Arduino code, from Adafruit that you don't need to do much modification. You just download the software and run it. You have to prove that, oh, I can use this screen, I can use this button, I can use this buzzer. And then you could use CNC or 3D printing to make your case, because this is fast and much cheaper than making the injection mold. We have to do very basic EE and ME tests. For example, if I have an electronic board and I have LED on the case, but the mechanical engineer forgot to add a hole, so the LED is useless. I cannot see anything underneath the hole. If I have a button designed on the edge of the board, but the mechanical guy does not add opening, so the button cannot be operated. So a lot of these details have to be cross-verified with both electronics and mechanical engineer. That's why we need to do basic EE and ME tests. And then the design phase, design verification. One very important thing is we have to lock down the design, which means we have to lock down how the device looks like. We cannot change the shape. We cannot change how it looks like. So you have to scale down your PCB. If your original PCB is this big, with an evaluation board and anything, but you're making the watch this big, you have to shrink it down until it can totally fit into the case. That's what we call it PCB scale down. You have to throw away a lot of unnecessary components. You have to put all your energy into this. And some people begin tuning sample, injection mold sample at this stage. Some people want to do it later. And also, what's important is to do ART and safety test, and also reliability test. So for those of you with your cell phones, you can take a look at the FCC and CE logo, because when you want to lock your PCB, you cannot change anything. And you have to make sure that your current design will satisfy the authorities' requirements, which means you can pass SEC, you can pass CCC. If you cannot, you have to definitely change it before DB stage ends. And then we'll come into PV stage, that you go with your factory, you do everything in the factory production line, even though you know the best about the product, but you can no more assemble the product yourself. You have to let a factory worker, maybe graduate from high school, maybe only 19 years old, to assemble your product. If they have any problems, you need to teach them how to fix it. You need to write down SOPs, standard operating protocols, to make them say, okay, first step, put the PCB here. Second step, put 4 screws on the corners. Third step, plug in the wire. The fourth step, check the product. So very, very simple. In one step, only do one thing. So they can very easily assemble and test your product. This is the PV stage. And the MP stage is more like mass production. You have to frequently travel to the factory, look at how the production goes, and talk with the manager, make sure everything could be done properly with your product. And QC, quality assurance, would be the primary concern in your mass production phase. This is another graph from Innozen Design that shows all the necessary supply chains. So previously, we were doing that from the product level, right? The product will evolve from idea, which is POC, to prototyping, engineering, and design verification, to production, product, and mass production phase. And then if we look at the supply chain, we will see that you first go from the design studio, you have an initial design, then you go with a rapid prototyping house to determine what kind of product you want to do, and then you split it up into 2 parts. One is mechanical, tooling factory, injection factory, spray factory, because a lot of things could be sprayed, even though for this one, for example, this pen has a skin touch service. That's due to a special painting material, special spray material they use. And on the other line is electronics. You have a design house or a design company. You do a PCB in the PCB factory, you do assembly or SMT in the SMT factory, and mount some through-hole components. And all these will go back to the final assembly plant or the final assembly factory that you combine your mechanical parts with your electronics parts and you put them all together. After that, you do packaging and you do certifications in this. So this is the whole process of a product, and that's how the factories are involved. So if we count this, we can clearly see that industrial design companies, hardware, electronics and mechanical factories, assembly, packaging, inspection, certification, shipping. All these companies can be found locally here in Shenzhen. That's why foreigners, Americans, Europeans, Africans, South Americans, maybe not people from the Atlantic or the Antarctica, but Australians, of course, they come to Shenzhen, they come to China to look for these kind of excellent resources. Because from the city center, you can go to any factory in 1 hour, 1 hour and a half, and a lot of Shenzhen people, they work 6 days a week, especially for startup companies. And for those of you who want to join a startup company, you have to be prepared for that. 6 days a week, not in school. And you could easily find the same kind of component or same kind of service provided by hundreds or even thousands of different companies. If you don't like company A, okay, go. If you don't like the first one, go to the second one. If you don't like the second one, go to the third one. Eventually go to the 1,000th one. Depends on you. You have the power, you have the decision to choose which one you like to work with and which one has the best quality. So a lot of these things are locally done in Shenzhen, and that's why we have a very good advantage compared with outside Shenzhen factories. So this is the truth about Shenzhen's advantages. And then we would do some little more introduction about the hardware companies. So this one is called View. It's right here. This is a smart glass for everyday use, and you can see that they raised $2.2 million on Kickstarter. That's a very high number. And these people were doing this glass because for people who wear glasses, they wear them every day, and you definitely could use the help of an assistant. So this one has 2 bone conduction speakers. They're not regular speakers, they're bone conduction speakers, which means this kind of thing will touch the surface of your skull, the bone, and use your bone as a conduction interface. So when you wear it, you could hear something from the, not from your ear, but from your skull, from inside your bone. That's how the bone conduction works. And this is the assembly of the wheel. You can see you have one battery here. This is the motherboard, and this is a small touch board. So the touch board used to have a touch interface on the side. So if I wear it like this side I can touch it and have some interaction or some control over this. You had some steps today and burned some calories. That's the message I just heard. Maybe you guys didn't hear it, but once you wear it, you can hear. This is the power of bone conduction. And you can also have optical lens, and this is the alter case of it. So View is a very stylish product, and apparently raising $2.2 million on Kickstarter is a very successful result. That's also the 2 founders, Jason Gui and Jiantian Zhang. They are listed on Forbes as 30 under 30. So Forbes select 30 people that are under 30 years old to be the top people in the industry that has contributions or has innovations to the human society. So you guys are below 30 now? How old are you?
23.
23. Oh, you have a long way to go. It's a good chance to get it. Yeah. So that's why when you make a good product, you are not only becoming rich, you're not only achieving your own dream, but also you are helping the entire society to innovate and to proceed in the way. Second one is called the Leaf. Leaf is right here. What's this? It's a special It's a special device that helps you to monitor your heart rate variability, and also your breathing. Because a lot of people, you might have anxious issues or pressure in your daily life, especially in Shenzhen. Your boss is, throwing bullshit on you. you don't have enough payments for your monthly rent. Your girlfriend breaks up with you. You need some drinks. Then this all happens in people across the world. So that's why the device is here. So this guy is Billy. He's the founder, and this device you can put on your body with an electrode pad. So what you do is you can monitor your heart rate, breathing rate, and just by mounting the pad, you could wear it all day. And they're working with doctors in the clinics to get it FDA certified, so that doctors can be using this device to teach the patients how to relax, how to control your own stress, or how to control your own body type. So I have a few electrodes left here. So after this session, if you want to try it out or experience it, that's okay. Let's leave. They use induction charging. So this whole device is wrapped inside silicon. This is the back cover. This is the top cover. So the whole device is waterproof. You can put it into water. You can have sweat on it. It's no problem. And they use induction charging. Induction means they use magnetic waves to charge the coils inside. That's why it can be done waterproof. And next thing is about M5 stack. So for whoever have played with hardware, embedded systems, microcontrollers, or something, you should have a painful period about finding the proper platform. This is STM32, it belongs to ST. This is Arduino, it belongs to ATmega 328. This is CC2650, it belongs to Texas Instruments. This is NRF51, it belongs to Nordic Semiconductor. So all these kind of manufacturers, they have their different product lines for the electronics MCU, and all these kind of different platforms require you to learn the different software, you have to learn different hardware, you have to learn from zero, you have to buy a lot of things, which is the surrounding part. And then for M5, they have all this one built with it. So you can use a standard stackable device to do your development. For example, where is the other? Here. This is the surface of the M5 stack. There's a small screen with a few buttons, and also some charging and connection interface on the side. But if you detach it, this is what's inside M5. So you could see the circuit board, you could see the connection, and also the Bluetooth Wi-Fi connection right there. So if you don't like this surface, you can change it to another surface and just put it back. It will just work. So what I have demo right here is a small game device. Okay, start. Super Mario, so you can use it on. So you can use it to play your games or to do some other creations. And everything is integrated inside this unit. And here is laser radar card that could help you with your AI training or with your navigation. So when you power it on, if you want to see, the radar on the top will start rotation, and that means this radar will consequently detect the surrounding location, surrounding areas, and this is the remote control. And on the screen, you see the blue dots and a lot of yellow dots. The yellow dots means these are the obstacles detected by this radar. So if I go forward, okay. The whole image changes. You can try it out later. But this is like a very general, very brief version about automatic driving. I'm not doing automatic driving, but if you have the radar working and you have your own program to recognize what's on the road, then you can use it one for driving. So that's the unfiled design. And not limited to these modules, we also have like ESP32 from Expressive. You have Wi-Fi, Bluetooth connection. This is an antenna module. This is a GSM module with a 2G connection. This is a LoRa module. It's also a wireless protocol. And this is a battery module, some prototype module, watch. You can put this one on your watch, and also some other faces. You can change it with a game controller. This one is a game controller, and this one is a keyboard. So whatever you want, you can find it with the M5 stack. They are a Chinese company based in Shenzhen, and they participated in the HACS program. So that's how it looks like, and it's very convenient for use. You don't need to know much about hardware. You just need to know how to type in some very basic English letters, and this one will work. Next thing is about ESOPO. So any of you know about Nintendo, the Japanese company, Nintendo. They make a lot of games, and Nintendo also released a gaming product. It's called the Switch. So Switch is a game console that in the middle is the motherboard and also the screen. You can detach it, the different Joy-Cons, and you can play it yourself or you can play it with your friends. So what's special with the Switch is it has a new way to determine or to define the gaming. For example, if you are hanging out with friends in a party or like a small environment, you can use the ESOPO projector. So this is a projector that projects the screen with a big with gaming. So you can see if I push on the light here, it starts to beam out image like this. And I could actually try to. This one also has a built-in speaker. So if I put the switch onto this one, the image will come out in a few seconds. So I'm playing. Can we turn off the lights a little bit? Okay, and maybe some here. Oh, that's good. So I'm playing a game. It's a boxing game, which we like. So what I need to do is just punch. So this is me, and I can also move myself. Jump, punch, yeah, and go back, punch. Okay, I'm not a good gamer, but this is how. Oh, I'm dead. Okay. So you can see that this one is very portable. You can carry the. Okay, so you can carry it anywhere you want. For example, when you go back home, you can do it like this on the ceiling. Or when you carry it with a few friends, you can just use any service to project. Because at night, you can really go very, very big. Like very, very big. I could be still bright enough for gaming. You can experience this later on once we finish the demo. So going back to the slides, for ESOPO, they do all the design and they do all the prototyping in China, in Shenzhen. So you can see that this part is the optical engine. It beams out the optics, and then there's a cooling design, two fans one fan for cooling down this LED optical engine. The other is to cool down the game console. And there's also a very big battery pack inside, so you could use it to project the images, and also you could use it to charge your own device. And it's a very fast speed. So in March 2017, Nintendo Switch, this game console was released. This one. And after 1 month, they have the idea about why not we do a product for Nintendo Switch, and then they want to do a projector. In July, the team was assembled. In August, they have the first prototype. In October, they started Indiegogo crowdfunding, and then by December 2017, the funding was successful. They had about $220,000 US on Indiegogo, and then they shipped their first batch in January 2018. That's very fast speed. Okay. So after introducing the companies, this is the last part. I'll be sharing some experiences about working in startup companies. So some people give this meme, like comparison between big corporations and startups. So in big corporates, you do a lot of things a day, but you repeat them every day. In startups, every day is hard, but you're making progress on your own and it's not repeatable. So if you wanted to join a startup company, you have to think about things in between. For example, working style is different. In big corporates, you have a clear roadmap, you have a clear schedule, you know what to do, and you know how to do it. It just needs to be done by yourself. But in a startup, you have to go that, oh, we need to ship by the end of this month. We need to solve this problem in 2 weeks, but nobody tell you how to solve it. You have to figure out your own way. You have to look for all kinds of available resources to solve this problem. And a lot of time it will fail. You have to delay your project. So this is very common for startup companies. And that's, another thing is about the skills. So in big companies, you want to concentrate your skills. You need to be as accurate as a smiter. Like if you're in Java, then you have to be very good Java developer. You could know nothing about C++. You could know nothing about embedded program. But in a startup, they want you to do everything. Okay, you're a software, right? Okay, carry this computer for me. Or write this Java, write this Python, write this C++, write this whatever language you use for you. So they want all the kind of things done by you because you are in this field. And there are not so many people in the startup company. And pressure, yes, big companies, maybe the first time you go there is a little bit tough, but as you get along well, you know what to do with your job and you get more laid back. But for startups, like your company, your boss sits right here. Sorry, your boss sits right here, and another boss sits right here. So they are always giving you pressure about building new stuff, and if you fail, you also feel very setback. So startups people normally have higher pressure than big corporates. Reverse. So in a big startup, in a big company like Huawei, Tencent, or some foreign companies, they have a clear payment dates, they have clear salaries, and you can know, oh, maybe in 10 years I can buy a house, maybe next year or in 3 years I can buy a car, I can do something, I can plan for a vacation or something. But in startups, it's like, sometimes there's a very good return, but if your company go IPO or if you have very good bonus out of the sales, but sometimes there's nothing. All the time, all the efforts you spend in the startup come back with nothing at all. And you just feel like you wasted your life or 3 years life with the company. There could be a condition. And next thing is about the risk. So of course, startups have a much higher risk than big corporates. I think that's it. Yeah. So if you want to join the startup, if you want to quit your current job and have your own company, you have to be prepared for all of this unexpected anytime. All right. So we'll start building your hardware, I think, because Shenzhen is a city for manufacturing for hardware, and if you have your idea about changing the world by making a small product or by making a small innovation, then you should try to utilize the resources in Shenzhen for doing hardware. If you're doing software, you could go to Hangzhou, Beijing, Shanghai, but if you're doing hardware, Shenzhen would be the best place in China and probably the best place in the world.
Congrats, Donny. Really, it was really good. I mean, it just makes me feel like I don't know anything in Shenzhen. I'm new here.
We can catch up later.
Sure. Thanks so much.
Yeah.